In this video, we are going to be looking at how to graph in standard form, a quadratic function given in standard form. And what does this mean? Standard form is when it's given as y is equal to ax squared plus bx plus c. So what are the steps? Step 1 is to find the vertex. And to be able to find the vertex, we need to identify the a, b, and c from the given equation. So this is the given equation. So let's start by finding the vertex. Remember, the vertex is given by x is equals to minus b over 2a. So from this equation, a is equals to minus 1. So minus 1. B is equals to 2. And c is equals to, so this is 2, and c is equals to 3. So I use my equation here. So this becomes minus b. So b is equals to 2 over 2a, and a is equals to minus 1. So that gives us 1. X is equals to 1. So when x is equals to 1, now I just need to get y. And remember, to get y, I just need to plug it into the equation. So this is going to be negative 1 squared. Remember, the equation has negative. It's negative, then x squared. So negative 1 squared plus 2, we multiply by 1, and then we add 3. So what do we get when we do that? So this is negative 1, this is 2 plus 3, 6, so we get 4. So that means the vertex is 1, the vertex is going to be at 1, 4. So this is 1, 4. So that's the vertex right there. And because a is negative, I know it's going to be opening down. So it's going to be maximum. So this vertex is going to be maximum. And what else do I know? I know a is negative, so I know it's going to open down. And now I also know the axis of symmetry since I got the x. So it's going to be x is equals to 1. Always remember, you write it as an equation. And see, I haven't even graphed it, but I know all this information. Compare to the graph of x squared, the parent function. So I know this is going to be facing down. It's going to be reflected. So reflected over x-axis. So I know I see a reflection. And what else do I know? It's also going to be, and the other information, I'll wait and see what else I'll be able to find out once I graph it. So now I need to generate some points. I already know the vertex, so I can start by graphing the vertex, which is 1, 4. So this is the vertex 1, 2, 3, 4. So that's the vertex right there. And I know it's going to open down. So what I'm going to do, I'm going to get some points on either side of the vertex. Actually, if I get points on one side of the vertex, I can be able to, if I start at the vertex, let me do my vertex right here. So I'm going to write it as 1, 4. Then I'll get some points and then use symmetry to get points on the other side. So I start with 1, I get 4, and then I'm going to plug in 2. When I plug in 2, I'm going to, I plug in 2. When I plug in 2, I'm going to get, when I plug in 2, what do I get? Plug in 2, I get 3, and then when I plug in 3, what do I get? I get 0. So when I plug in 2, I get 3 right there. When I plug in 3, I get 0. See, I can use, since I know my axis of symmetry is right here, my axis of symmetry is over here, I'm going to reflect these points. So this is the point. I just counted 1, not exactly there. So the other point, I just count 1, so I just count 1, and then 1, 2, 1, 2, the other point is going to be there, and then those are enough points for me to connect, and I get my graph right there, and that's my graph right there. What else can I be able to see from this graph? Remember, I know that the stretch is the same width because the absolute value of A is 1. So I'm also going to say it has been translated one point to the left, 1 step to the right, not left, and then it has also been translated 4 steps up. Okay, now let's. So here is another example. We have the equation, and let me start by finding the vertex. And to find the vertex, I just use the formula minus b over 2a. So this means minus b, so minus 4 over 2 times 2. So that means I get negative 1. So once I get negative 1, how do I proceed from this point? Once I get negative 1, I just need to plug it into the equation to get y. So y is going to be 2, and then negative 1 squared plus 4 times negative 1, and then plus 1, and this is all going to equal, for y, what do I get for y? So I work all this out, and this should give me negative 1. Okay, so now I have my vertex, so my vertex is negative 1 and negative 1, and since a is positive, it's going to open up. So what does that mean? So it's opening up, so this is going to be minimum, my vertex, and the axis of symmetry is going to be x is equals to negative 1. So, and then I'm also going to compare it, but let me complete my table. Again, I'll start from my vertex, and then I'll get some points using symmetry. So negative 1, so it's going to be right there. Then I'm going to plug in 0, and I get 1, and then I can also plug in 1, I get 7, and let me see what I have so far. So 0, 1, so this is the other point, and the other point is 1, 7, that's the other point, and I think those are enough points. I just now need to use my line of symmetry, which is right here, to reflect the points on the other side. So this is the other point, and then 1, 2, 1, 1 2 1 2. Okay, and now I just need to connect my points with a smooth curve, and there is my graph. And what can I tell about my graph? So I can, let me write all the transformations I see here. So it's going to be, I see it's narrower, so vertical stretch, and I can also say it's translated. How many units down? 1 unit down. And what else can I say? Translated 1 unit left, 1 unit to the left. So those are the transformations. And we go to the next one, and in this one we are going to look at some examples, and here we are told to state whether the function has a maximum or minimum, and then state the minimum or maximum value. So how am I going to do that? Just read the question again and think of how you would be able to work this out. The first thing I would look at is the value of a, and I see a is -3. Let me also write the value of b, and the value of c is equals to -6. So c is equals to -6. So this is 12, and c is equals to -6. Now I need to, I can see it's going to open down, so that means it's going to be maximum. And so now let me find that maximum value. So how do I do that? I'm going to find the vertex. So x is equals to minus b over 2a, which is equals to minus 12 over 2 over minus 3, and this is going to give me 2. So when I get x is equals to 2, I can find y by plugging it into the equation. So I have -3, then I have 2 squared plus 12 multiplied by 2 minus 6. So what do I get? I get 6. So now check what I have here. I have my vertex, and my vertex is 2, 6. And what does that mean? So remember, it's a minimum. So the minimum value, be careful about this one. So the minimum value is given by the y value. So the minimum value is 6. So that is the answer. And in the same way, you would do the next example. So you find your minimum and maximum value. And I'm going to give you the answer here so that you can work it out. And pause the video, work it out. So when you do this one, you're going to get the vertex as -5, -19.5. And then here, the minimum value, actually, the minimum value is going to be -19.5. And I'm going to fix something. Do you see a mistake that I made here on this? last example. Remember I said that this was the maximum, was a minimum here, so I should have written maximum because it's opening down, and this one, because it's positive, I know it's going to open up, so this has to be a minimum value. So that's how to do that.